Hello, and welcome to Math Matters. I'm Ms. Granados, and today we are going to consider ways we can solve word problems. Before we begin, you'll need some paper and something to write with for today's lesson. I'll give you about 20 seconds to gather those materials. Let's start with a number talk image. How many do you see? Can you see it in a different way? What equation would match the way you thought about it? Okay, what do you think? Maybe you said there were 13 four-leaf clovers. Did you see them in 3 groups of 4 with an extra one, like this? Or maybe you saw them in 2 groups of 4 and a group of 5, like this. Or perhaps you grouped them into pairs and counted by 2s and added one more, like this. Or did you see it a completely different way? I bet some of you thought about the number of leaves in all. How did you figure it out? I thought about the number of leaves on one clover. I counted them 1, 2, 3, 4. And then I remembered how many total clovers there were, 13 clovers. And I multiplied that by 4, or 4 leaves. So I know 10 clovers would have 40 leaves, since 10 times 4 equals 40. And then there are 3 more clovers to count. And I know 3 times 4 is 12. So then I'll add the number of leaves on 10 clovers, 40, and the number of leaves on 3 clovers, 12, and that'll make 52. So this image has 52 leaves. Great job thinking through this image. Let's move on to our problem. Have you ever walked on a beach and seen some little animals moving quickly across the sand? If so, you probably saw a ghost crab. Ghost crabs are also known as sand crabs because of their sandy color. The cool thing is they can change their coloring to match their surroundings in order to avoid predators. They're also called ghost crabs because they can disappear quickly. I bet they move quickly because of all the legs they have. How many legs do you see on the ghost crab? Yep, they have 4 pairs of legs, or 8 legs total. They also have 2 front claws to help them with their food. Let's read our problem for today. Zachary counted blank crab legs when he went for a walk on the beach. How many crabs were there if he counted blank legs in all? What is it that Zachary counted? Crabs or crab legs? Let me read the first sentence again. Listen closely. Zachary counted blank crab legs when he went for a walk on the beach. So what did he count? Yeah, he counted crab legs. How many legs does the ghost crab have again? That's right, 8 legs on one crab. So what's the question we're trying to answer? Well, we want to know how many crabs Zachary counted. So now let me read it again with the numbers. Zachary counted 48 crab legs when he went for a walk on the beach. How many crabs were there if he counted 48 legs in all? Let's think about this in a different way. Do we know the number of groups, the amount in each group, or the total? The 48 crab legs he counted is the total number of legs. We also know that a ghost crab has 8 legs, which is how much in each group. So what are we missing? Yeah, we're missing the number of groups. In other words, the number of crabs he saw. Think about what strategy you might use to solve this problem. I'll give you a few minutes, and then we'll look at a couple of student strategies. If you solve it one way, try to solve it a different way. All right, let's take a look at how a couple students solve this problem. First, we'll start with Suzi. She began with 48 legs, and since she knew that each crab had 8 legs, she subtracted 8 legs from the total of 48 legs. Then she continued to subtract 8 legs until she got to 0 legs. Why did she stop at 0 legs? Suzi stopped at 0 because then she knew that she used up all 48 legs. So where's the answer of how many crabs she saw on the beach? Exactly. Suzi added up how many times she subtracted 8 legs, knowing that each 8 legs represented one ghost crab. The equation that Suzi wrote to match her strategy is 48 divided by 8 equals 6. 48 total legs divided into 8 legs in each group to make 6 crabs. Why do you think Suzi's strategy worked for a division problem? What is division? Yeah, division's the opposite of multiplication. And since we know that multiplication is repeated addition, multiplication and division are opposites of each other, we could say that division is repeated subtraction. So in Suzi's strategy, she used repeated subtraction to solve a division problem. Will this always work? You bet it will. Shawn had a different strategy. Shawn knows that 2 groups of 8 are 16. He multiplied 2 times 8 again to get another 16, and then added the 16s to get 32. He still wasn't at 48, so he multiplied 2 times 8 again to get another 16. And then he added 16 to the 32 to get 48. What does the 8 represent in 2 times 8 equals 16? Yeah, 8 legs on 1 ghost crab. Well, what about the 2? Well, that's 2 crabs. So 16 is the number of total legs found on 2 crabs. What's the 32? That's 32 legs on 4 crabs. So how does Shawn know to stop at 48? Well, yeah, because that's the number of legs that Zachary counted. So to figure out how many crabs Zachary saw, Shawn added all the 2's and got 6. So 6 times 8 equals 48, which in this problem means that 48 legs are on 6 crabs. Take a look at these 2 strategies. What do you notice about them that are the same? What's different? Well, I noticed that they both knew that crabs have 8 legs. So they either subtracted by 8 or multiplied by 8 to figure out the answer. They also both got as an answer that 48 legs are on 6 crabs. Something different about their strategies is how they counted. Suzi skip counted backwards by 8 and subtracted 1 crab at a time, while Shawn multiplied 2 times 8 3 times. Where is Shawn's 2 times 8 equals 16 in Suzi's strategy? Well, it's in her last 2 subtraction problems. 2 groups of 8 legs make 16 legs. The groups in both of their strategies represent the 2 crabs. You can see the second 2 times 8 equals 16 in Shawn's strategy in the middle 2 subtraction problems in Suzi's strategy. Do you see where the last 2 times 8 equals 16 in Shawn's strategy is? Located in Suzi's strategy? You got it, in the first 2 subtraction problems. This shows that you can solve a division problem with repeated subtraction or multiplication. Another difference I see is in their number sentences. Suzi wrote a division equation while Shawn wrote a multiplication equation. Remember yesterday we talked about how multiplication and division were closely related? Well, you can see here that you can use multiplication to solve a division problem. When we start with the total and look for the number of groups, like in this problem, we started with the total number of crab legs that Zachary saw and we're looking for the number of crabs, then the problem is a division problem. But the way you solve it can be division or multiplication. The important thing is to remember what each number represents, either the total, the number of groups, or the number in each group. In this problem, we know that 6 is the number of crabs, or groups, 8 is the number of legs, or the number in each group, and 48 is the total number of legs. We can say that 6, 8, and 48 are part of a fact family. Let's review the relationships between multiplication and division. What is division? Well, we know that division is the opposite of multiplication. And since we know that multiplication is repeated addition, and that multiplication and division are opposites of each other, could we say that division is repeated subtraction? Well, in Suzi's strategy, she used repeated subtraction to solve a division problem. Will this always work? It surely will. Let's take a moment to reflect on today's learning. How can you use a fact that you already know to help you solve facts you don't know? What is something you feel good about with multiplication and division? Take some time now to share out or write down your thoughts to those questions. So today we solved a division word problem and compared two different strategies. On your own, solve this problem on another sheet of paper. Elena counted 72 crab legs when she went for a walk on the beach. How many crabs were there if she counted 72 legs in all? Try to use one of the strategies we looked at today, or try a new strategy. For Math Matters, I'm Miss Granados, and I hope you have a mathematical day. Keep on counting.